we're not going to do DI today. We're just going to do tap water. Okay, so that's one aspect that we're going to try to speed this up a little bit. Okay, so the data analysis section. In both cases of alkaline hardness, I put a data analysis section with the percent of each of the parts. Okay, so this is exactly what Dr. Thomas is talking about that we're going to have to do. 10% is always going to be how complete your lab report is. Okay, all the sections, the EPA standards, regulation, the calibration, the standardization, all that good stuff has to be in there. There's no calibration today because you're not using any equipment. So there's some good news, okay? No standardization, no calibration. It's just your eyeballs. This is all about color change and kind of seeing when the color changes based on the pH change, okay? So completeness, determine the alkalinity in milligrams per liter of calcium carbonate. So skip that DI water, just going to be tap water. We talked about that. Statistics, we're going to have statistics on each of these three columns. The usual statistics, okay? Mean, standard deviation, standard error, confidence interval, all three columns, okay, no problem there. This is the alum hypothetical that we were talking about earlier. So if we add this particular concentration of alum, we're given the molecular weight, we're adding it for coagulation purposes, determine the amount of alkalinity consumed, okay, and based on the equation that we talked about, Dr. Thomas talked about at the end, you can use 25 milligrams per liter of alum times a half, based on what Dr. Thomas talked about, or you can use the equivalent weights, which is 50 equivalent weight calcium carbonate over 100 equivalent weight of alum, which is the same as 1/2, which is a half. So either way works, okay? Whatever you can think about it best. So that's a pretty straightforward calculation. Then the question asks, is this, whatever you come up with here, is it greater than or less than what you came up with in your titration? Pretty straightforward. So once you get this number, you compare it to that number of alkalinity consumed and see which one is greater. Okay? So those are the 5 pieces. Pretty straightforward, but keep that in mind because I'm going to grade for these pieces. Okay?
That's a good point Sherkanto made. That's where that half comes from. It's the equivalent weight ratio. Because it asks you, and the reason you have to do that is because it says, what's the concentration in terms of milligrams per liter calcium carbonate? Right. They could ask you what's the concentration of it, and then you can just use the molecular weight, but you have to use the equivalent weight ratio because it said calcium carbonate.
Yeah, and everything's standardized to calcium carbonate in these types of calculations because it's kind of the common standard. Now for the hardness piece of it, there's 2 pieces, all right? There's a calcium hardness and there's a total hardness, okay? So 2 separate titrations you'll be doing, 2 different color changes we'll be looking at, 2 different types of chemicals that we're gonna use, the same titrant, but different indicators, okay? So make sure you make that distinction in your lab report, calcium hardness versus total hardness. What's the difference? Well, as Dr. Thomas talked about, the calcium hardness is basically your calcium carbonate. The total hardness includes your magnesium. Okay, so the first thing we're going to do is the calcium, so we're going to measure the calcium carbonate. The second calculation or determination we're going to make is the total hardness. So the difference between those 2 numbers would be what? Your magnesium hardness. All right? You have total minus the calcium, you have your magnesium left. Okay? So keep that in mind as we're running through this. Lab report again, determine the different hardness for tap water, calcium and total. Statistical analysis, same type of stuff. And then calculate the concentration. So once you know what your hardness is, you can calculate the concentrations of this in calcium, in milligrams per liter of calcium carbonate, using your equivalent weights. Okay? So we can, once you get there, we can talk to that a little bit if you don't remember how to do that. And then over here it talks about, is this amount acceptable? Well, there's a secondary drinking water standard that the EPA has. Anybody know what that is? For magnesium? It's 40 milligrams per liter. Okay, so once you come up with your concentration here, compare it to the 40 milligrams per liter of calcium carbonate and then see if it's greater than or less than the EPA secondary standard. Okay? And then this is the biggie, the softening. that Dr. Thomas is talking about now. So once you get all your numbers, you can create the bar graph. You can figure out where all your anions and cations lie, and then you can figure out the amount of lime and soda ash, if there's lime and soda ash needed to soften, depending on where your anions and cations line up in your bar graph. Okay, so this is kind of the big part that we're talking about, and this is using the selective calcium removal, like example 11.7.
Right, yeah, that's the one
Yeah.
you did refer to example 11.7.
Yeah. So I think that example will tie right into this, but you'll have your actual numbers in this example versus what they give you in the book for 11.7. So, but use the same process. So those are the 50% for this lab. Break it up in 2 different labs, and then you guys should do well on this one. This is the toughest one. I think it's the toughest lab of the semester. From here, it's all kind of coasting downhill a little bit, so to speak. It's not simple, but this is the most labor intensive, the most chemistry intensive that you have to deal with. So just kind of bear with us this week. Okay. So we're going to do alkalinity first, okay? So what I need you guys to do